Now, from a limit perspective, vertical asymptotes occur when you take the limit as x approaches a from the plus side or minus side of a, and you get plus or minus infinity. So, when I take the limit as x approaches a from the minus side of f of x, if I get plus or minus infinity, or if I take the limit as x approaches a on the plus side of f of x and get plus or minus infinity. When I get an infinity answer for a limit, that tells me that x equals that a is going to be a vertical asymptote. Okay? Now, I did this problem and I broke it up into these three problems on the awesome pre-section video that hopefully you guys have already watched on it. So, I'm going to focus on number 2 since I did the other ones actually on the pre-section video here. But you're supposed to watch the pre-section video and go take notes off that thing. So here, I want you to do this problem. I mean, and the way I'm going to put it on any kind of weird test for you guys is I'm not going to signal, find the vertical asymptote. No, I'm just going to ask you to do this. Take the limit as x approaches 2 of x plus 1 over 2x minus 4. And this is the work I expect to see. What's the first rule of limits? Plug it in. So let's plug it in. This is equal to 2 plus 1 over 2 times 2 minus 4. 2 plus 1 is 3. 2 times 2 is 4. Minus 4 is 0. And there's my signal right there. What do I got? A number divided by 0. That tells me that x equals 2, the number that I'm going for, x equal, is going to be a vertical asymptote. But we're supposed to calculate this limit. When you get a number divided by 0, remember, there's 3 different possible answers for this guy. The answer is either going to be infinity, negative infinity, or does not exist. Remember, this is a full limit. So to figure out what the answer is going to be, is you're going to have to do the chart. We're going to take the limit as x approaches 2 from below of the function x plus 1 over 2x minus 4. And we're going to take the limit as x approaches 2 from above of the function x plus 1 over 2x minus 4. When you do the one-sided limits from below or from above, and you get a number divided by 0, the answer is going to be either infinity or negative infinity. You just got to figure out which one. But this is how you show your work. So, we're taking the limit as x approaches 2 from below. So, I'm slightly less than 2. What kind of numbers am I going to plug into this thing? Something very close to 2, slightly less than 2. So, for x numbers here, I'm going to plug in 1.9 and 1.99. As I just mentioned to you guys, when you take a limit as x approaches a number and you get a number divided by 0, the answer is going to be either infinity or negative infinity or does not exist. And when you do your one-sided limit, the answer is either going to be infinity or negative infinity. It's guaranteed. All I got to do is figure out which one. So, to figure out which one, we're going to do the t-bar. And all you got to do is plug in 2 numbers. Catch a pattern. Am I going to be blowing up? Am I going to be blowing down? You can't just plug in one number and identify it, because I can mess you up on that one. Because how many times have I plugged in a number and I got negative, and then all of a sudden you get really close and it switches around and goes up the other direction or something or other. Be careful on that. That's why you always do 2 numbers and look for the relationship between the 2. Am I blowing up or blowing down? So here we go. Turn my calculator on here. And parentheses around your numerator. Plugging in for x 1.9 plus 1 divided by parentheses around the denominator 2 times 1.9 close parentheses minus 4 close parentheses around the numerator, parentheses around the denominator. What do I get? I got negative 14.5. Okay? Now, plug in 1.99. Get a little bit closer and see what direction. Is this thing going to go negative, or is it going to turn around and go positive? As you get really close, you'll begin to tell the direction here. That's why you always plug in 2 numbers. So I'm plugging in now 1.99, and I got negative 149.5. So as I approach 2 from below, from the less than side, what am I approaching? I went from negative 14 to a negative 149.5. Where's it going? Negative infinity. So therefore, the limit as x approaches 2 from below of x plus 1 over 2x minus 4 is actually negative infinity. That's the answer for that one right there. Now, take the limit as x approaches 2 from the plus side of x plus 1 over 2x minus 4. We already know when we plug it in, I got 3 over 0, so the answer is going to be positive infinity or negative infinity. So we're going to do, once again, that incremental approach. So now I got to plug in numbers very close to 2, slightly bigger than 2. So we're talking about 2.1 and 2.01 to see what's going on here. So here we go. Parentheses, 2.1 plus 1 divided by parentheses 2 times 2.1 close parentheses minus 4 close parentheses for the denominator, and I get 15.5. I got close. Now I'm going to get a little bit closer to see what direction am I going. That's why you have to plug in at least 2 points on this thing. So now I'm going to plug in 2 point, insert a 0 there, 2.01 plus 1 divided by 2 times 2.01 minus 4, and I end up getting 150.5. So now, as we take the limit as 2 goes to, as the limit is, we go to 2 from the plus side, 2.1 to 2.01, what's my function approaching? 15.5 to 150.5, dot, dot, dot. Where am I going? Positive infinity. This is infinity. Now, boom, 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 boom. 3 dots in a triangular fashion means therefore. Can you tell me what is the limit as x approaches 2, the full limit of x plus 1 over 2x minus 4 is equal to? Well, remember, from the left side of 2, I'm going down to negative infinity. From the right side of 2, I'm going to positive infinity. They're not going to the same thing. So therefore, by strict definition, what's my limit? You got it. Does not exist. No solution. This guy doesn't have a limit because they don't go in the same direction. If they don't go in the same direction, that old adage that the limit does not exist will always hold. But if they both blew up, infinity and infinity, then I would say the answer is infinity. If they both blew down, if this was negative infinity and this one also negative infinity, then the answer would have been negative infinity. But if they go into 2 different infinity directions, the limit still doesn't exist. Like I said, when you take a limit as x approaches of some function, and you get a number divided by 0, the answer is going to be one of 3 answers. It's either going to be infinity, negative infinity, or does not exist. And this is how you show your work. Does that make sense? But, continue on. That's about vertical asymptote stuff. Now, there's another concept we want to talk about, and that is the limits as infinity. A limit as the domain approaches infinity. The limit as x approaches infinity of f of x. We can also do infinities. Limit as x approaches infinity, or negative infinity if I want, of a function. Now, understand this. It's up to this point, when it comes to limits, there are 3 cases. What are the 3 cases of limits, once again? First rule of limits, called the substitution method if you want a fancy term here. First rule of limits, take a limit. First rule, plug in a number. If I get a number, I'm done. Second rule, when I take limit as x approaches a of f of x, I plug in a number and I get 0 over 0. What am I supposed to do? Do algebra. Factor, simplify, cancel, maybe some kind of weird conjugate or some other one. It's a square root problem. Do some kind of algebra to try to cancel it if you can. Step number 3. When I take a limit as x approaches a of f of x and I plug in a number and I get a number divided by 0, not 0 over 0, then I got to do the t-bar on these guys like I did up here, and the answer is either going to be infinity or negative infinity or does not exist depending on the case. Now there's going to be a case 4. This is a special type of limit. We're going to be taking the limit as x approaches positive infinity of f of x and the limit as x approaches negative infinity of f of x. Now, here is the idea. But before I put that idea up here, and again, watch the awesome pre-section videos on this thing, but let me talk about this little special note. It's not in your notes, so write this in your notes. Here's the idea. If I take the limit as x approaches infinity of 1 over x to p, where p is a positive power. What will this thing be going towards? For example, what's the limit as x approaches infinity of 1 over x? We'll do x to the first power. Well, think about it. X is getting really big, you know, 1,000,000. What is 1 over 1,000,000? By definition, 1,000,000th, right? Microscopic. What is limit as x approaches infinity? 1 over 1,000,000,000. Plug in 1,000,000,000 for x. What's 1 over 1,000,000,000? 1,000,000,000th. That's even smaller. So what am I going towards? 0. This is a rule. It has to be a positive power here, but when you take the limit as x approaches, and it's either plus or minus infinity, 1 over a negative 1,000,000 is negative 1,000,000th. That's still 0. Okay? So it's either plus or minus infinity. Take the limit as x approaches plus or minus infinity of 1 over x to the p, you're going to get 0. That's a known fact. So, knowing that fact, here's a trick on how to do the limits of infinity of rational functions. So we give you the kind of description here. Determine the degree of the denominator. When we're talking about rational function, we got a polynomial over a polynomial. Focus on the degree of the denominator. Let's say it's p. And then the second step is this. You're going to multiply the numerator and denominator by 1 over x to this p. See, 1 over x to the p divided by 1 over x to the p is a ratio of 1. It won't change your function at all. But you can distribute, and you can get a bunch of numbers divided by x on the bottom. And then when I take my limit, I know those guys are going to cancel out. Those always go to 0. And then I'm going to distribute, clean up my algebra, and evaluate the limit using this property right here. So I can talk about this all day long, but it works better if I actually do some examples. Now, I know I did these problems on the old video, but just for understanding purposes, I'm going to do them again. Okay? So, I want you to take the limit as x approaches infinity of 6x squared plus 2x plus 7 over 8x plus 2x squared. Now, in a little bit, I'm going to show you a trick that you can look at these problems and tell what the answer is even before you start. I mean, how hard is math if you can look at it and go, oh, clearly the answer is going to be 3. Oh, awesome, dude. Okay? I can look at it and tell what the answer is going to be. But how much credit do you get? 10-point problem up here. How many points are you going to get if you have the answer? It's perfect, circled. The answer is going to be 3, trust me. But there's no work involved. That's right. You're going to lose 15 points on a 10-point problem. That's right. You can make a negative grade on my test because you didn't show me the work. This is the work I want to see. I'm going to show you the trick on how to look at this stuff and see what the answer is. But if the work doesn't match up to that, you lose it all and then some. Okay? So, here's the steps. Step 1. What is the degree of the denominator? 2. So I'm going to multiply both the numerator and the denominator by 1 over x squared. 1 over x to the degree of the denominator. These are my steps. It's degree 2. It comes from that dude right there. Now, next step is I'm going to distribute this 1 over x squared throughout the numerator and throughout the denominator. It changes the form of my problem. This gives me the limit as x approaches infinity of, let's see here, 6x squared times 1 over x squared. What's that? 6, because the x squared is canceled. Plus 2x times 1 over x squared is 2 over x. Plus 7 times 1 over x squared is 7 over x squared. I distributed and cleaned it up. Now, distribute the 1 over x through the denominator. What is 8x times 1 over x squared? 8 over x. See, it's 8x over x squared, but one of the x's cancel. I'm just cleaning it up as we go. Plus, here we go, what is 2x squared times 1 over x squared? Well, x squared's cancel, you're left with 2. Now, using our property of limits, we can distribute the limits through every x in thy function, and that means in the numerator and in the denominator. But here was the rule. Remember we talked about this. When I take the limit as x approaches either plus or minus infinity of a number divided by x to a positive power, those fractions always go to what? 0. You know, that 2 over a million is a millionth. That goes to 0. And this is 7 over a millionth squared. That's going to go to 0. Those denominators get bigger. The fractions go to 0. What am I left with? 6 plus 0, which is 6, over 0 plus 2, which is 2. And that's right. Simplify. 6 divided by 2 is 3. And that's what my answer is. But we got to see the work. I will show you how to look at it and tell what the answer is in just a second. Let's do these two problems here. Take the limit as x approaches infinity of x cubed plus 4x minus 2 over 6 minus 2x squared. This, once again, is a limit as x approaches infinity. Don't do this 1 over x to the degree of the denominator trick if you're doing a regular limit. Limit as x approaches 2 of x cubed plus 4x minus 2 over 6 minus 2x squared. You just plug in a number and try to factor and try to cancel some stuff out if you got 0 over 0. Don't do this, because you know what people do. You do a regular limit and they're going to do now everything's got to be 1 over x to the degree of the denominator. No, it doesn't work like that. Only when you take the limit as x approaches either plus or minus infinity do I do this. What's the degree of the denominator? What's the degree of the denominator? 2. So I'm going to multiply both the numerator and denominator by 1 over x to the degree of the denominator, 2. Now I'm going to distribute. This will give me the limit as x approaches infinity of x cubed times 1 over x squared is what? X plus 4x times 1 over x squared is 4 over x minus 2 times 1 over x squared is 2 over x squared. Now distribute the denominator. 6 times 1 over x squared is 6 over x squared. Minus, what is 2x squared times 1 over x squared? 2. Now take your limit as x approaches infinity. All the fractions with the x's in the denominator are going to kill each other off. There's a problem with this one. There's an x that's not in the denominator. Now this one will go to 0, this one will go to 0, this one will go to 0. You are left with, so you got to keep writing limit here, limit as x approaches infinity of, what's left in the numerator when all the zeros go away? X. What's left in the denominator? Watch your sign, -2. Now, take the limit as x approaches infinity. Plug in infinity and follow your nose. Infinity divided by 2. Congratulations, you just won the lottery. You know, you just won $500 million in lotto or whatever it's called, right? Congratulations. I got a question for you. What's the first thing you have to do when you win the lottery? That's right, pay your tax. And how much taxes will the government take on winnings? Exactly, 1/2. So you just won $500 million. Guess what you get to take home? $250 million. Sounds unfair, but who cares? You just got $250 million. So my question to you is this: what's half of infinity? Still infinity. You're good to go. But pay attention to signs. What is infinity divided by -2? What's a positive infinity divided by a negative number? Follow your nose. The answer is negative infinity. Best answer to this one. Follow the signs. Let's take a look at number 12 here. Take the limit as x approaches infinity of 2x divided by 2x squared plus x minus 1. What is the degree of the denominator in this problem? 2. So I'm going to multiply the numerator and denominator by 1 over x to that power right there, x squared. That's the trick in showing my work. The 1 over x degree of the denominator, and you do whatever you do to the denominator, you do to the numerator, makes it a perfectly legal math move. I only do this with infinity limits. I'm going to distribute. This will be equal to the limit as x approaches infinity of 2x times 1 over x squared is 2 over x, divided by 2x squared times 1 over x squared is 2, plus x times 1 over x squared is 1 over x when you simplify it, minus 1 times 1 over x squared is minus 1 over x squared. Now, when I take my limit as x approaches infinity of the fractions where x is in the denominator, by our rule, these guys all go to 0. So what am I left with? This thing goes to 0. This term goes to 0. This one goes to 0. What am I left with? 0 divided by 2. And what is 0 divided by 2? 0. Does that make sense? Now, let me show you the trick. When I take the limit as x approaches infinity of some function, or when I take the limit as x approaches negative infinity of a function, I'm really asking you, as x gets bigger and bigger and bigger, what is the function doing? Is it leveling off to a particular number? Is it blowing up, or is it blowing down? What do you call it when a function, as x gets bigger and bigger and bigger positively, or bigger, bigger, bigger negatively, aka it's getting smaller, as these things level off, these are called horizontal asymptotes. So when you take the limit as x approaches either plus or minus infinity, you're actually finding the horizontal asymptotes of the function. Does that make sense? But from high school, we had a theorem about horizontal asymptotes. And I've rewrote it down here. All right. Here it is right here. For positive integers m and n, such that m is greater than n, the degree of the numerator is equal to the degree of the denominator. When you take your limit as x approaches infinity of these polynomials, you're going to get the ratio of the leading coefficients. That's going to be your horizontal asymptote, and that's going to be answer to the limit. Because the limit as x approaches infinity is a horizontal asymptote. If the degree of the numerator, the top, is bigger than the degree of the denominator, the bottom, when I take my limit as x approaches infinity of these two guys, I'm either going to get plus or minus infinity. The thing's going to be what they call an oblique or slant asymptote thing here. But I got to follow my nose on this one. It's either plus infinity or minus infinity, and I won't know which one it is until I actually do the work. So I got a 50-50 shot on that one. And the third one is when I take my limit as x approaches infinity, and when the degree of the numerator is less than the degree of the denominator, degree of the top is less than the degree of the bottom, I'm going to get 0, the horizontal asymptote y equals 0, every time. So, my point to this is this. With these limits as x approaches infinity or negative infinity of these rational functions, I can look at them and tell what the answer is. Here we go. Because when I take the limit as x approaches infinity, it is the horizontal asymptote theorem. What is the degree of the numerator here? Look at that function, 6x squared plus 2x plus 7. The degree is 2. What is the degree of the denominator? 8x plus 2x squared. 2. So when the degree of the top equals the degree of the bottom, the answer is the ratio of the leading coefficients. Remember, leading coefficient is connected to the degree term. So the leading coefficient of the numerator is 6. The leading coefficient of the denominator is 2. And 6 divided by 2 is what? Yep, there's the answer, 3. I knew that 15 minutes ago. Take a look at this one. When I take limit as x approaches infinity of 2x divided by 2x squared plus x minus 1, the degree of the numerator is 1, x to the first. The degree of the denominator is 2. The degree of the top is less than the degree of the bottom. When the degree of the top is less than the degree of the bottom, what do I get? 0, every time. And look at this one here. On this one, when I take limit as x approaches infinity of x cubed plus 4x minus 2 over 6 minus 2x squared, the degree of the numerator is 3. The degree of the denominator is 2, aka the degree of the top is bigger than the degree of the bottom. Then the answer is going to be either plus or minus infinity, and I don't know which one it is until I actually work the problem out. But I guaranteed I got a 50-50 shot. It's either going to be infinity or negative infinity. So if this is a multiple choice answer, A, the answer is infinity, B, the answer is negative infinity, C, the answer is 2, 3, D, the answer is 0, E, the answer is 45. I can kill off the last 3 answers. I got a 50-50 shot on this one. But if I actually show my work, and remember, follow your nose, positive infinity divided by negative 2 makes it a negative infinity, you'll get the answer. It's the horizontal asymptote theorem. Does that make sense? So, how can we mess you up with this stuff? Oh, very simply, don't give you polynomials. So take a look at the next one. They're polynomial-like, but they're tricks. And I have to describe the trick to you. Here's the one. Take the limit as x approaches infinity of 3x minus 10 divided by the square root of 16x squared plus 5. This is not a polynomial divided by a polynomial rational function because I get a big old nasty square root in the denominator. But if it had a degree, what would the degree be? Is going to be the game. Well, remember, when you're doing these, when you do the limit as x approaches infinity, you always have to have a fraction. Let me repeat that. When I do the limit as x approaches infinity or negative infinity, I always have to have a fraction. Well, I got a fraction. I just happen to have a square root in the denominator. So, what is the degree of the denominator if it had a degree? Officially, it doesn't because it's a radical function here. But the degree is the highest power of x. What do we got going on here? I got the square root of the x squared. What's the square root of x squared? Square roots and squares cancel, so what am I left with? So the degree would be officially x to the first power. Degree would be 1-ish. Does that make sense? So I'm going to multiply by 1 over x in the numerator and 1 over x in the denominator. Perfectly legal math move, just like we did before. But I got to play a trick. Because I'm going towards positive infinity, listen to my words, the 1 over x, to be able to get it inside the square root so I can distribute and do the same trick as I've done before, I've got to rewrite 1 over x with a square root. And 1 over x is the same thing as 1 over the square root of x squared. That's the same thing, right? But now I can combine radicals and get something underneath the square root so I can cancel and make my little fractions again. But listen, I'm taking the limit as x approaches positive infinity. I'm going towards positive infinity on this one. So this ratio, even though I replaced it with this, is the same thing. What's 1 over positive infinity? Yeah, I know it's going towards 0, but it's positive. 1 over a positive number is positive. Plug an infinity on this thing. Infinity squared is infinity. Square root of infinity is still infinity. This is still 1 over infinity. The numerator and the denominator are the same thing, so that's why it's still a ratio of 1. So now I'm going to plug and put the x squared part underneath each term there. And this, the 1 over x, I'm going to distribute. So this would be equal to the limit as x approaches infinity of, what's 3x times 1 over x? 3 minus, what's 10 times 1 over x? 10 over x. Now we're combining these two radicals here. So it's one big square root. Square root divided by a square root is still a big old square root. But now the x squared is going to get distributed inside. What is 16x squared divided by x squared? 16, again combining the square roots, that's why the x squared goes inside, plus what is 5 times, or divided by x squared inside my radical? 5 over x squared. Remember, that 1 over the square root of x squared, combining the two radicals, the 1 over x squared gets to distribute through the denominator. Does that make sense? That's where the 5 times 1 over x squared gives you 5 over x squared from. Now let's do the same trick. When I take my limit as x approaches infinity, my little fractions go to 0. And what am I left with? 3 minus 0, which is 3, divided by the square root of 16 plus 0, which is the square root of 16. Clean it up. What's the square root of 16? 4. What's my answer? 3/4. I know what you're thinking. Well, can't I just look at that one too and tell what the answer is? Because once I identify the square root of x squared as like an x, and I see the 3x to the numerator, then isn't the same thing as the ratio of leading coefficient almost like? Yeah, it's almost like that. You can, but no work means no credit, and minus extra points because I don't want to look at that crap. Does that make sense? Got to show me the work. But there's a trick. I just showed you the trick. Watch the next one. Take the limit as x approaches negative infinity. Oh, we're messing you up now. We're going to go after negative infinity here. Let me blow this up a little bit. You guys can see this a little better. Take the limit as x approaches negative infinity of the square root of 9x squared plus x plus 1 divided by 2x plus 1. Well, it's still a limit of infinity, whether it's plus or minus, it doesn't matter. You still got to do the identify the degree of the denominator and then multiply the numerator and denominator by 1 over x to that power. But this one's a trick. So what is the degree of the denominator? Well, the denominator is 2x plus 1. So what's the degree of it? 1. So I'm going to multiply both the numerator and the denominator by 1 over x. Does that make sense? But this guy's a radical. So therefore, I have got to rewrite 1 over x so I can have it have the x in terms of a radical, so I can get some stuff inside my radical so I can make my little fractions again. So what is 1 over x in terms of a square root? Well, what did we do before? 1 over x was equivalent to what? 1 over the square root of x squared. But you got a problem. Let me show you the problem. What do we take in the limit as x approaches? What is it? Negative infinity. So my denominator is 1 over negative infinity. Now granted it's going to 0, but officially 1 over a negative number is negative. Here's the problem. Once you write it like this, that 1 over x is 1 over x squared, but you're going to negative infinity. What is negative infinity squared? What's a negative infinity times a negative infinity? Positive infinity. And the square root of positive infinity is positive infinity. So this is 1 over infinity, but this one was 1 over negative infinity, and those two dudes aren't the same thing. It's not a ratio of 1. So here's the trick. Because you're going after negative infinity, this guy's going to be negative, but when you do the square root of x squared, that's positive, so you got to put the negative in front of the square root, because remember, when you do square roots, you've got two options, a plus square root or a minus square root, and when you do the limit as x approaches negative infinity, you need the negative square root on this dude to make the ratio the same. So now, when I plug in negative infinity, whenever negative infinity is negative, getting smaller, this is negative infinity squared, which is positive infinity. Square root of positive infinity is positive infinity, but with the negative out front, we're back to negative infinity. This is 1 over negative infinity. This is 1 over negative infinity. Now we're like terms. It's a ratio of 1. Now I'm going to distribute through the denominator. And remember, I'm going to have to distribute and combine with the numerator. Watch what happens. This is equal to the limit as x approaches negative infinity. The denominator is pretty straightforward. 2x times 1 over x is 2, plus 1 times 1 over x is 1 over x. But remember, you've got to combine radicals. This is a positive square root divided by 1 times 1 over a negative square root. That's divided by a negative square root. What's a positive square root divided by a negative square root? It's a negative square root when you combine them. And now the x squared can go inside my big radical here. I have to combine radicals. Positive square root times 1 over a negative square root makes it a negative square root. And the x squared goes inside. 9x squared divided by x squared is 9. Plus x divided by x squared is plus 1 over x. And 1 times 1 over x squared is 1 over x squared. But you had to combine radicals. So again, and the best way for me to describe this is a trick when you go into doing the negative infinity. Now you can go ahead and finish up this problem. When I take my limit as x approaches negative infinity, when the negative infinity is in the denominator, these fractions still go to 0. So 1 over x will go to 0, 1 over x squared goes to 0, 1 over x goes to 0. What am I left with? Negative the square root of 9 divided by 2. So what is my answer on this one? Negative 3/2. Now, we know what you people do on web work. You do it the same way as you did the first one, even though this was a negative infinity. You type in and you get 3/2, and you type in 3/2. Web work says it's wrong. So you think about it for a second. Oh, that's a negative. So you chuck a negative in front of it, and then web work tells you you're right, and you feel like you've done something. No. Pay attention to this. When it's a negative infinity, you got to show your work on this stuff. We want to see that negative 1 over the square root stuff. Show your work on this one. So here's the deal. With these interesting radicals, remember, when you take the limit as x approaches positive infinity, you're finding the horizontal asymptote as x gets bigger and bigger and bigger. When you take the limit as x approaches negative infinity, you're finding the horizontal asymptote as x gets smaller and smaller and smaller. So you really can have two different asymptotes, one for positive infinity and one for negative infinity, and they don't have to be the same thing. And this would be, if you actually graph this thing, you would see that one. If you go to positive infinity, the answer would actually be 3/2, but negative infinity would be negative 3/2. It actually has two asymptotes on this thing, horizontal asymptotes. All right? Some other proper problems you guys need to do is this one. Take the limit as x approaches pi halves from below of the tangent of x, and take the limit as x approaches pi halves from the plus of tangent of x. Now this one is very straightforward, and basically 15 and 16 question here is basically your understanding of, you guys know what the tangent graph looks like? Draw with your fingers what the tangent graph looks like. Yep, it's a squiggly line, but it's a trig function, so it's periodic. So I'm going to graph this thing down here. So a tangent graph is periodic between pi halves and negative pi halves. And at pi halves and negative pi halves of the tangent graph, you basically have vertical asymptotes. And over here at pi fourths and negative pi fourths, the tangent of 0 is 0, the tangent of pi fourths is 1, the tangent of negative pi fourths is negative 1, but as you get close to pi halves, it goes vertical. And as you motion with your fingers, this looks almost like a square root graph, but it's bounded. Does that make sense? Because it's periodic. A cube graph. The squiggly like a cube graph, but it's bounded between negative pi halves and pi halves. But it's periodic, which means you come over here, and over here at 3 pi halves becomes your next vertical asymptote. And over here at pi, the tangent would be 0, and it's periodic, so you end up getting the same picture. And it keeps duplicating itself forevermore. It's a periodic function. Does that make sense? So now, here comes my question. What is the limit as x approaches pi halves from below? So here is pi halves. Here's my target right here. If I approach pi halves from below, where's my function going? It's going, pi halves is a vertical asymptote. It is going which way? Two options. It's going up. So what would the answer be for the limit as x approaches pi halves from below of the tangent of x? Positive infinity. It's blowing up. However, what is the limit as x approaches pi halves from the plus side or the positive side? From the positive side of pi halves, where that would be on your next periodic function, and where is the tangent going on that side? It's going down to negative infinity. And this is just knowledge. There's no showing me a graph pretty much does it for me. This is to work on these kind of problems. So would you ever see a problem like this on the test? No, I'm just giving you the answers right now. But I could do a cotangent graph or something like that, or a cosecant graph where they have some vertical asymptotes on it. And this is how, by drawing the picture, you can tell me why these things are what they are. One side is going to be positive infinity, the other side is going to be negative infinity. Last problem for today here. Now, here we go. I want you to take the limit as x approaches infinity of the square root of x squared plus 7x plus 1 minus x. First rule of limits, what you going to do? Plug it in. What is infinity squared? Infinity. What's 7 times infinity? Plus 1. So infinity plus infinity? Infinity, you're a billionaire. Plus one more dollar? What does it matter? You're still a billionaire. And what's the square root of infinity? Infinity. So this is infinity minus x is going towards infinity. It's infinity minus infinity. Another type of indeterminate form. What's infinity minus infinity? Well, it depends. Do they cancel and get 0? Well, yeah, sometimes, if they're the same infinity. But, you know, it could be things like this. There's different kinds of infinities out there. You know, the Bill Gates infinity and the Oprah Winfrey infinity. They're both billionaires. You know that, right? But who's got more money? Okay, Bill Gates. So if I take Bill Gates and subtract off Oprah, what we got? Still a billionaire. He's got loads of billions, you know. So Bill Gates minus Oprah is still infinity. We'll switch it around. What is Oprah Winfrey minus Bill Gates? Negative infinity. So officially, if they're not the same infinities, you can get an infinity answer. You can get a negative infinity answer. They can cancel and get 0. You can do the Bill Clinton case. You got Bill Clinton minus Hillary Clinton. Well, pretty much they got the same money from Saudi Arabia or somewhere. So they got the same amount of money. So when you subtract these two guys together, you know, let's say they got divorced or something or other. What do you got? Nothing. The lawyer gets it all. It'll be 0. Or maybe Bill Clinton's got $45 more than Hillary Clinton does. Who knows? And though the answer is 45. It's indeterminate. You can't tell what infinity minus infinity is. And here's the other deal. I told you guys that when you're doing a limit as x approaches infinity, you got to do fractions. They have to be in this fraction form. So the first thing you got to do when you do a limit as x approaches infinity is make it a fraction. You feel better about it? It's a fraction. But it's a radical. So what is the trick on cleaning up radicals? What was my trick? Conjugates. So because of the square root of x squared plus 7x plus 1 minus x, I'm going to multiply. The trick is going to be conjugate here. I'm going to multiply by the square root of x squared plus 7x plus 1 plus x. What I do to the numerator, I do to the denominator. X squared plus 7x plus 1 plus x. Now, when we do conjugates, we're going to FOIL it out. FOIL out conjugate pairs. Now, help me out here. What is the square root of x squared plus 7x plus 1 times the square root of x squared plus 7x plus 1? X squared plus 7x plus 1. Outer would give me plus x times the square root of x squared plus 7x plus 1. The inner would give me minus x times the square root of x squared plus 7x plus 1. And one more, what is negative x times positive x? Negative x squared. 1 times the square root of 7x, 1 times the square root of x squared plus 7x plus 1 is square root of x squared plus 7x plus 1 plus x. Now, with the foiling of the conjugate pairs, what cancels? The outer, inner always cancels, but in this one, something else cancels. What is it? X squared. So it makes it feel better. I now actually have a fraction. And I am going towards positive infinity of, this would be 7x plus 1, that's what's left in the numerator, divided by the square root of x squared plus 7x plus 1 plus x. Does that make sense? Now, now I have a fraction. What is the degree of the denominator? There are two terms in the denominator. It's the square root of x squared, and there's x. What's the square root of x squared as a degree term, even though it doesn't have a degree? It'll be 1, and x to the first is x. So this really is, even though it's two terms, the degree is x. So I'm going to multiply both the top and bottom by 1 over x. Same old trick. And I'm going to distribute, but once I distribute 1 over x to the radical, I got to rewrite that as 1 over the square root of x squared. Which one do I take? Plus, or do I take the minus 1? You take the plus because this is positive infinity. You take the minus 1 when it's a negative infinity. And this one I'm going to distribute. So I'm going to be left with the limit as x approaches infinity of 7x times 1 over x is 7 plus 1 over x. Now inside my radical, I'm going to divide by an x squared. So this is the square root of x squared divided by x squared is 1 plus 7 over x plus 1 over x squared. But be careful, there's one more term, plus x, and x times 1 over x is 1. So now, when you take your limit as x approaches infinity, all the little fractions go to 0. Please tell me what you're left with. 7 over the square root of 1 plus 1. What's the square root of 1? Plus 1. So what's my answer? So now to answer the age-old question, what is infinity minus infinity? 3.5. Study these problems well. We'll start chapter 2.1 on Tuesday. No Friday review session. See you guys on Tuesday.